Hi everyone, it's Mrs. Martello. We're going to look at lesson 2.4 today. I'm on page 74 in the online textbook if you want to follow along. And we are going to be solving multi-step inequalities. So before we jump in, I just want to remind you of how we go about solving multi-step inequalities here. So our first step is always to simplify each side of the equation. Remember, we're going to distribute and then combine any like terms that we can. So getting our equation as simplified as possible before we start to solve. Our second step is if there are variables on both sides of the equation, we need to get the variables on the same side. You don't necessarily have to do this, but I find that it's easier to get the variables together first and then start worrying about isolating the variable. So that's our next step. Step number 3 is isolate the variable. So you get rid of the constant term and then you get rid of the coefficient, just like how we did with equations. Just remember that if you multiply or divide both sides of an inequality by a negative number, you have to remember to flip that inequality symbol. So don't forget about that rule as we go through solving these inequalities here. All right, let's take a look at example 1a. We have y over negative 6 plus 7 is less than 9. So we're going to solve for y. We're going to subtract 7 from both sides. Y over negative 6 is less than 2. And then we have to get rid of this negative 6 because it's being divided. Let's multiply both sides by negative 6. And because we're multiplying both sides by a negative number, remember I have to flip that inequality symbol. So now it becomes greater than. We get our answer y is greater than negative 12. And then the directions said to graph the solution. So I'm going to put negative 12 with an open circle. And I'm going to shade to the right because it's greater than. Let's look at B. 2v minus 4 is greater than or equal to 8. We're going to add 4 to both sides. We get 2v is greater than or equal to 12. Divide both sides by 2. V is greater than or equal to 6. And then we can graph it. Close circle on 6 because it's or equal to. And we're shading to the right because it's greater than. Okay, let's take a look at example 2. Okay, in example 2, we can see now we're going to have variables on both sides. So I want to first get the variables on the same side. Since 2x is the smaller variable, it's better to do that first. So why don't we go ahead and subtract 2x from both sides. I'm going to actually show my work for this one. So this is example 2. Now I know that the book does the constants first, but I personally find that it's better to do the variables first. Technically it doesn't matter, but again, I think it's better to do the variables. So again, since the 2x is smaller, let's eliminate the smaller variable so that I'm left with a positive coefficient. 4x minus 5 is less than 11. Let's solve. We're going to add 5 to both sides. 4x is less than 16. And then we can divide both sides by 4. We get x is less than 4. Okay, and then the directions here did not say that we have to graph the solution, so we are done with that problem here. We don't have to do anything further. Okay, but look at how they got the same answer even though they did the constants first. I just personally like doing the variables first. I think it's better. Okay, let's talk about our special solutions. We did have special solutions when we had equations. We're going to have special solutions with inequalities too. Remember, these happen when the variables cancel. If all the variables cancel out and we're just left with numbers, that's going to leave us with special solutions. If we have a true result, for example, like 2 is greater than 0. Well, yeah, 2 is greater than 0. The special solution that we're going to use in this case is all real numbers. The solution is all real numbers. Now this is very similar to saying infinitely many solutions like how we did with the equations, and sometimes you'll see them used interchangeably, but there are infinitely many real numbers. There's also a symbol that stands for all real numbers, and it looks like this. You do 2 vertical lines and then you draw an uppercase R with both of those vertical lines. This symbol here means all real numbers. If the result is false, again, all the variables canceled out, you're just left with numbers like 2 is less than 0. Well, that's false. So that means that the solution is that there are no solutions. That means that there are no numbers that can be the answer. Remember, the symbol for no solution is a circle with a line through it. You can use that symbol too, or you can say no solution. Let's take a look at these examples. So in example 3a, we have 8b minus 3 is greater than 4 times the quantity of 2b plus 3. On the right, we need to distribute so we can simplify. Then we're getting the variables on the same side, and when we subtract 8b from both sides, we're left with negative 3 is greater than 12. Notice all the variables canceled out, and we're just left with numbers, and this is a false result. So because this is false, that means that there is no solution, which means I cannot pick any number I could ever try that I could plug in for b. It would never make this inequality true. Let's look at example 3b. 2 times the quantity of 5w minus 1 is less than or equal to 7 plus 10w. On the left, we're going to distribute and simplify to get 10w minus 2. Then we're going to get the variables on the same side, subtract 10w from both sides, and both of these variables cancel out. We're left with negative 2 is less than or equal to 7. That is a true result, so that means that all real numbers are the solutions. Okay, we're going to look at a real world problem here. We're going to look at number 31 as our real world problem. And I'm going to squeeze it in on my paper over here, number 31. Okay, in this example, we are looking at an ATM machine. Write and solve an inequality that represents how many $20 bills you can withdraw from an account without going below the minimum balance. So think about how we want to write our inequality here to describe, and then we'll solve it. Remember, when you write your inequality, we want the current situation with the variable, then we'll have our inequality symbol, and then we'll have the result over here on the right. Okay, so let's think about what we have here. We have our current balance. Our current balance is $320. That goes with current. We are withdrawing $20 bills. We don't know how many $20 bills we're going to take out, but we know it's $20 per bill. Since we're withdrawing, we're going to subtract 20b. So we're subtracting $20 per bill. We know that the minimum balance is $100. So the money I have in my account has to stay greater than or equal to $100. So that would be our inequality we would write, and now we can solve for b. So I'm going to subtract 320 from both sides, and I'm left with negative 20b is greater than or equal to, be careful when you're subtracting here. If you want to use your calculator, that's totally fine. 100 minus 320 is negative 220, and then we're going to divide both sides by negative 20. Now be careful, we're dividing both sides by a negative number, so I have to remember to flip my inequality sign. So b is less than or equal to, let's divide by negative 20, and I get 11. So that means that I can take out at most 11 $20 bills.